In the last worksheet, we saw that chemical reactions could be used as recipes. Here's a recipe for making ammonia out of air. Ammonia is NH3, and we take some N2 out of the air and we react it with hydrogen. Now let's balance this, because we're going to need a balanced equation here. If there's 2 nitrogens on this side, I better put a 2 there. And if I put a 2 there, there's 6 hydrogens on this side, so I better put a 3 there. So there's my balanced recipe for making ammonia from nitrogen and hydrogen. Now suppose I have got 2.0 moles of N2 and I have 4.0 moles of H2. And I want to know how many moles of NH3 am I going to get? Alright, we're going to do this the same way that we did the sandwich making problem in the last video. We are going to predict the amount of product for each ingredient, for each reactant. So I'm going to take my 2.0 moles of N2, that's one of my ingredients, and I'm going to turn that into some amount of ammonia. And I'll make some amount moles if no one tells me otherwise, because it's easy to work in moles. And I'm going to take my 4.0 moles of H2, the other ingredient, and figure out how many moles of NH3 I would get from that. So let's do that. Okay, if I'm going from N2 to NH3, I need a mole-to-mole ratio. Whenever you're going from one substance to another, you need a mole-to-mole ratio. I need a mole-to-mole ratio between N2 and NH3. If I look at my reaction here, there's 1 mole of N2 for every 2 moles of NH3. So I'm going to end up with 2 times 2 is 4.0 moles of NH3. Let's do the same thing with the hydrogen. I'm going from H2 to NH3, so I need a mole-to-mole ratio to do the conversion. I know moles of H2 has to go on the bottom, and moles of NH3 has to go on the top, because that's what I want. So I look at the balanced equation. There's a 3 with the moles of H2, and there's a 2 here. So it'll be 4 times 2 is 8, divided by 3, so that's 8/3, so that's what? 2.67, something like that. Really, this should be to 2 significant digits, so I could write 2.7 there, but let's not worry about that right now. So what's it going to be? Which amount of NH3 am I actually going to get? Well, we saw in the last video that you're always going to get the lesser amount. And I don't do anything further with that. I just throw the result of that calculation away. It's the one that gives you the lesser amount of product that you're going to take as your answer. Now, the reactant that gave you the lesser amount of product is called the limiting reactant. It produces the lesser amount of product and it is completely used up. In the reaction. There'll be no hydrogen left after this reaction goes. Now what about the amount of excess? How much N2 will be left over? how much N2 is going to be left over after the reaction is done? Well, we know 4.0 moles of H2 are going to be used up. Let's figure out how much N2 is used up from that. So you start with the amount of limiting reactant that you have here, and you can figure out how many moles of N2 are used up. Okay, so 4 moles are used up because that was the limiting reactant. Let's turn moles of H2 into moles of N2. We know moles of H2 have got to go on the bottom, and moles of N2 go on top. So I've got 3 moles of N2 for every 1 mole of 3 moles of H2 for every 1 mole of N2. So this will be 4. This will okay, sorry about that. This will be 4/3. That's how much N2 is used up, but we want to know how much is left. Now, we initially had how many moles? 2? So if we subtract the amount that was used up, that's going to give us the amount that's left over. Okay? So what is it, like 0.67? So, before the reaction we had 2 moles of N2 and 4 moles of H2. After the reaction, we're going to have 2.67 moles of NH3 with 0.67 moles of N2 left over. We know that the H2 is the limiting reactant, so it is all used up and there is no H2 left after we're done.